Welcome back, everybody. In this video, we're going to look at several different applications of displaying measures of center using box plots, dot plots, and we'll try to answer some questions about those. This problem here says the graph compares shoe sizes for a group of 100 two-year-old boys and a group of 63-year-old boys. About how many more two-year-old boys have a shoe size of 6 or less compared to the 3-year-old boys? All right, well, first thing on here, we want to identify size 6. All right. Size 6 for the 3-year-old boys corresponds with Q1, the first quartile, meaning this amount of the data is 25% of all 3-year-old boys surveyed. So we're going to figure out 25% of the 60. That is 1/4 of the 60, which is 15. All right. So 15 of the 3-year-old boys had a shoe size of 16 or less. Now compare that to the 2-year-olds. That is the median, also known as Q2. And from here to here is representing 50% of the data, 50% of all of the 2-year-old boys. And there were 100 2-year-old boys. And if we're talking about 50%, that's half of 100, which is 50. And then what's the difference between those two? 50 minus 15, 35. This answers the question. There were 35 more 2-year-old boys that had a shoe size of 6 or less. On the next problem, we're trying to determine which measures of center are the most appropriate given these statements here. We're going to pick one statement that seems to be the truest. It says daily number of customers at a dry cleaner over 8 days are 80, 75, 68, 74, 63, 81, 79, and 68. Which statements are true? All these are talking about mean, median, mode, so we'll take the time to compute each one. If we add all of these up and divide by 8, comes out to 73.5. It's our mean. Our median, if you line them up, least to greatest, we have our two middle numbers, 74 and 75, making the median 74.5. And the mode is the number that appears the most. The mode is 68. Now, given that looking at these three, how the mean and median are closest together, that would make probably the most true statement. Mode is kind of a distance. It's a little bit further away from the mean median than the mean and median are to themselves. So yeah, 68 does appear twice, but it isn't as close to the measure of center as the mean and median. So we're going to choose A here for the best statement. For this one, we have the amount of water the girls on the basketball and soccer teams drink during one practice session is recorded on the dot plots. We'll put our answer to complete the sentence here. Median ounces of water drank on the basketball team was about blank less than the median ounces of water drank on the soccer team. Okay, median. First, we're going to count each of these up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 data values. We have 12 down here as well. To find the median, we're going to need the 6th and 7th. 1, 2, 3, 4, 5, 6, 7. Here's our 6th and 7th. To average those two, that gives us 32. It's our median ounces of water drank on the basketball team. And then we'll do the 6th and 7th over here. 1, 2, 3, 4, 5, 6. Here's the 6th. And here's the 7th. All right, so that's 72 plus 80. And then we want to divide that by 2. 152 divided by 2 looks like 76 for our median. All right, so we have 76 and 32. If we take 76 and subtract 32, we are going to get 44 for an answer. About 44 less than the median for water drink on the soccer team. That's how much less the basketball team was. In this example, it says Tom made box plots to compare the number of calories between his morning snack and afternoon snack. Type your answer to correctly complete the statement. And the statement is Tom's typical afternoon snack has about blank more calories than his typical morning snack. Okay, I'm going to use typical. Based on the box plot, the thing we really have to go on is our median Q2. His morning snack was 150. And the afternoon snack right down there in the middle, the median of that looks like 375. All right, and if we take 375, subtract 150, I believe that comes out to 225. So on average, typical median of each one. On the afternoon, he was eating more, 225 more calories than the morning. And finally, here we're going to compare box plots, talking about the range of a set of data. John made box plots to compare the number of calories between his morning snacks and afternoon snacks. Put the right number in to complete this sentence. The range of calories of John's morning snacks is about blank more than the range of calories in his afternoon snacks. So range, meaning the min minus the max. First, let's look at morning. Looks like the minimum here is 75. The maximum, 325. We take 325 minus 75. We're looking about 250. That's the range of the morning now, the range of the morning. All right, let's talk about the range of the afternoon. We're down here at 275 approximately for the minimum. The maximum here is at 500. All right, so we have 500, subtract 275, we get 225. And if we are going to subtract these two, 250 minus 225, that's simply 25. There we go. I hope this video helped shed some light on using visual representations, box plots, and so forth, dot plots, to talk about mean, median, mode, range, other measures of central tendency. Thank you for watching. Leave any questions in the comments below.